Just going to look at special triangles again, and it is going to be part 2, so learning more specifically about the casserole today, using some of that language that we used yesterday. So to warm up, we're just going to find our principal angle that is coterminal to 495 degrees, negative 150 degrees, and 920 degrees. So remember, when you're doing this, it can only be in increments of 360 degrees to find anything that's coterminal. So 495 degrees minus that 360 degrees. Remember, your coterminal angle, your principal angle has to be between 0 and 360 degrees, and it's a positive angle. So you can't add 360 degrees here because you're going to be way above 360 degrees. So it's going to be 135 degrees. And you know that that is your principal angle there. As well, again, you can't subtract negative 360 from this example because it would be a negative angle. Principal angle has to be positive between 0 and 360 degrees. So you're going to take that negative 150 degrees and you're going to add 360 to it here. And then you're going to get 210, so it's a positive angle. And then here again, 920 is way too big. We're going to have to subtract 360 degrees at least once. That's 560. And then that's still too big. Subtract another 360, which is 200 degrees. So that is your principal angle there. If you want, you can, of course, always just draw your angle. So for the first one, you could draw 495 degrees. So you know that you're going around all the way once, plus then you're going all around all the way again to about 135 degrees. And then that would be your coterminal angle to 135 degrees as your reference, or your principal angle here of 135 degrees. So it just depends. You don't have to use the diagram, but you can if it helps you visualize it a little bit better. Find the related acute angle to 240 degrees, 115 degrees, and 325 degrees. So for that, it's probably easiest if you do draw it, just so you can visualize it, but sometimes you might get used to it once you have more practice. But so here, if you just draw a 4 quadrants, you know that this is your 0, 360 degrees, this is your 90, this is your 180, and this is your 270. You can draw that 240 degrees, so you know it's somewhere in between here, and you know that that is, let's go big here, that's your 240 degree angle. And then you want to find the related acute. Remember, main thing for related acute is that it is between your x-axis and your terminal arm. So it's going to be here, is going to be your related acute angle. And to find that related acute angle, you're just going to take that 240 degrees, which is your principal angle, and subtract the 180 degrees, and you're going to get 60 degrees. So in this angle here, it is 60 degrees. Okay, so you're going to do that the same thing for all 3 of these. Just want a different color. Let's go back to red. So you can draw, again, draw your principal angle of 115 degrees, and then you're going to, let's go green this time, find where the angle between the x-axis and that terminal arm. So that's going to be your RRA there. So to find that one, this time we're going to take that 180 degrees, which is your bigger angle, and subtract that 115 degrees. So you should get an angle of 65 degrees there. And then lastly, you're going to draw your XY plane again, mark off 325 degrees. And then you are finding your RAA in between, magenta, your x-axis again, never your y-axis, and your terminal arm. So that's your RRA in there. Again, take your bigger angle. So your bigger angle is that 360 degrees. from your, that 360 degrees from your x-axis, and subtracting that 325 degrees, and then you are going to get 35 degrees in there. So that angle in there is 35 degrees. So that should be a warm-up from the previous lesson. And now we're getting into something that would be known from you from last year. But if you remember, it's called the CAST rule. So the CAST rule is a special rule used often as a memorization acronym in trig. Essentially, CAST stands for cosine, all, sine, and tangent. So you can see the C is that cosine, all is the A, sine is the S, and T is the tangent. Okay, so starting in quadrant 4 and going in a counterclockwise fashion, the CAST rule will tell us what trigonomic ratios, cosine or tan, are always positive in said quadrants. So if you look here, you're looking at your quadrants here. You're starting in quadrant 4, so down here, and it's going to tell you which ones are positive. So in quadrant 4, cosine is going to be your positive. In quadrant 1, every single sine, cosine, and tan is going to be positive. In quadrant 2, just your sine would be positive, and in quadrant 3, just tan, which means for cosine that this would be negative sine, negative tan, positive cosine. All three of these, so you have positive sine, positive cosine, positive tan here. You have positive sine in quadrant 2, negative cosine, negative tan, and then in quadrant 3, you have positive tan, negative sine, negative cosine. Again, that will make more sense once we do more questions with them, but they're ultimately just to tell you if something is positive or negative. Okay, so some examples here without a calculator, so they're really easy to plug in a sine of 170 into your calculator and tell me if it's positive or negative, but you will start to get used to it, and you should know that your answer is wrong if you are thinking if it's positive or negative. So here we have sine of 170 degrees, so it's probably easiest if you draw 170 degrees on your table. So that's approximately 170 degrees, give or take. Okay, so now you're looking at the quadrant. So quadrant 2, it says sine is positive. Since we have a sine ratio, you are using sine positive. You know that this will be a positive answer. Again, draw out 210 degrees. So you're going to, here, I'll switch colors. So you're going to draw out 210 degrees, which will be somewhere about here. 210 degrees. You are in your positive quadrant. That tan is positive. It's quadrant 3. Since you're looking at your tangent, you know that it is going to be positive in this quadrant. And your answer, if you plugged in tan of 210 into your calculator, would be positive, not negative. Okay? So let's look at negative 235 degrees. So that one will be somewhere about, switch colors, somewhere about here in your second quadrant. So negative 235, remember you're going clockwise. So negative 235. You're looking at cosine. However, where does that fall? It falls in the sine is positive quadrant. So it has to be negative because you know that in this quadrant, sine is positive, but cosine is negative and tangent is negative. So you know that this answer would be negative. Okay, now we're getting into using some exact values, which means that we need to use our special triangles. Special triangles are not new for you. You should have learned them last year. And they just are going to use some exact values, so you're not going to ever see decimals. You're going to see like the square root of 2, maybe the square root of 3, for different things like that. Approximation would be if you were to round that. Okay, So we have our first special triangle, which is your 45-degree special triangle. And with your 45-degree special triangle, it will help you to figure out your sine, cosine, tan ratios. So with that, you can use 45 degrees is the same. So let's just use this one at the bottom. Okay. So this would be your opposite. This is your hypotenuse, and this is your adjacent, again, from our first lesson. And then you know for sine, it would be opposite all over hypotenuse. Your opposite is 1. Your hypotenuse is root 2. So you would get 1 all over root 2. Again, we're using exact values, so you're not going to go and put that in as an approximation in your calculator. We're going to leave it like this. Okay. For cosine, it would be adjacent over hypotenuse. So again, 1 all over root 2, that 1 and that root 2. Again, you leave it like that. You don't change it to an approximated value. Okay. For tan, we're going to go opposite, which is 1, all over 1, which is just 1. So for your special triangle of 45 degrees, these are going to be your exact values that you're going to get used to and comfortable with in lots of examples. Okay. So for this example, and where you're going to see this stuff, is when I ask you to find the exact value for sine of 135 degrees. So for this, you will know, if you draw it, there's 135 degrees. Okay, and then you will know that your related acute angle would be in here. It would be 180 degrees minus that 135 degrees, which is 45 degrees. So you know that your related acute angle is 45 degrees in there. Okay. However, for this example, I'm going to have a triangle come up on there, so I just need to get rid of that writing. You are going to be able to use your special triangle without plugging this in on a calculator. I need an exact value, so you need to be able to use your special triangles. You know that it is going to be sine, which is opposite all over hypotenuse, so the answer is going to be 1 all over root 2. Remember, CAS, its sign is positive in this quadrant, so your answer will be positive 1 all over root 2. Okay, again, for cos of 225, if you were to find your RRA, it's going to be 45 degrees because that's the example we're doing right now. But draw 225 degrees, you get that RRA of 45 degrees there. I know it's sideways and it looks a little confusing, but you're still labeling the triangle the exact same way. So your 1 and your 1 are on your opposite and your adjacent side, and then your hypotenuse is that root 2. It's the exact same triangle as the previous slide, the same triangle as here. It will never change. Okay, so here you're looking for cosine. Cosine would be adjacent, so this 1 all over root 2. However, it's in what quadrant? It's in our tan quadrant, which means it's negative cos and negative sine, and only tan is positive there. So you need to have that negative sign there as well. Okay. Then let's look at tan of 315 degrees. So draw that 315 degrees. Your related acute angle would be 45 degrees here. Again, the exact same triangle drawn. It's just upside down essentially. And we're going to look at tan. So tan would be opposite all over adjacent. So it's going to be 1. Remember though, it is in the cosine positive tangent, which means that negative sine and negative tan fall in this quadrant, so it's not just 1, your answer is negative 1 there as well. Here's our second special triangle that you're going to use exact values for. Again, a little bit more confusing this time because last time we had 45 degrees here and 45 here, but now we have 30 and 60, so we're actually going to have to switch our triangles up and our ratios up a little bit. So let's use 60 degrees first. So here's going to be your opposite, here's your hypotenuse, and here's your adjacent. So root 3 all over 2 is your ratio for sine of 60. For cosine, so looking at your sine of 30, cos of 30 and tan of 30 degrees, you're now going to use that as your reference angle to label the triangle. So this would be opposite, this would be your hypotenuse, and this would be your adjacent. And you're going to get 1 all over 2 for your sine. For cosine, adjacent all over hypotenuse would be root 3 all over 2. And then for tangent, you're going to get opposite over adjacent, so 1 all over root 3. So a little bit more this time, because there's double the amount of exact values, but you will get used to them as we keep going through lots of examples using them. So again, these ones are all going to give you related acute angles of either 30 or 60 degrees for these examples. So here you're going to mark your 330 degrees on here, which gives you a terminal arm around there. And then you should be able to know that your RRA, getting comfortable with this now, would be 360 degrees minus that 330 degrees. And then that's going to be 30 degrees in there. So you know that your triangle is going to come up with 30 degrees in there. You're looking at tan, which is opposite all over adjacent, so 1 all over root 3. But again, remember that you're in your cosine tangent, so cosine quadrant, so you're going to have negative sine and negative tan, so that answer needs to be negative there. Okay, so cos of 120, again, draw that terminal arm of 120 degrees. Your RRA here is going to go and be 180 minus that 120, so you're going to get 60 degrees. So you're going to label your triangle according. So 60 degrees, root 3 over 2 goes opposite. Your hypotenuse is 2 and your adjacent is 1. Again, you're looking at cosine, so adjacent is 1 all over 2. But again, in your sine quadrant, you have negative cos and negative tan, which means that that answer needs to be negative. And for this last one, you're going to mark that terminal arm of 210. Your RAA is going to be 210 degrees minus 180 degrees. And then that is going to be your 30 degrees. So that's how you're going to label your triangle there. So you know that's 30 degrees. And you're looking for sine, so you're looking for opposite, so 1 all over 2 there. You are in your tan quadrant, so it's going to have to be negative as well. So lots of examples there with negative ones. And don't worry if this is super confusing, where our whole next lesson is basically going to be going over the steps on how to do this as well. Okay, we're just getting used to those exact value triangles right now. Okay, and then here's kind of a thinking question. So what would the dimensions be if the hypotenuse was 1? So normally you have your 45 degree triangle here. So let's look at that one first. You normally have root 2 as your hypotenuse. But what if we wanted it to be 1? Well, what are you going to do to that root 2 to get it to be 1? What do you need to divide it by? You need to divide it by root 2, which would give you that 1. But what you do to one side, you have to do to the others. So you're going to go root 2 and divide by root 2. So we would generally label this 1 over root 2 here and 1 over root 2. However, something that you would have probably run into in 11U, possibly not in 11UC, but is something called rationalizing your denominator. So in math, we just don't like final answers to have a root or a that symbol there in the denominator. We like it to just be a number. So all you're going to do there is to get rid of that, you're going to take that 1 all over root 2. And it's really easy. You're just going to multiply the numerator and the denominator by whatever the root is in the bottom. So it's going to be root 2 times root 2. If you did that in a calculator, your answer would be 2. And then 1 times root 2 is root 2. So your final answer actually that you're going to put here and in here are going to be root 2 over 2 rather than that 1 all over root 2. So you can see that those two answers there. again, just something little and small in math. You won't see it come up too much in this course, but just for understanding where you would get this and why you would see it in your textbook like that. Okay. Now looking at this one, well, if we're originally starting with a hypotenuse of 2 and we're getting to 1, what do you need to divide 2 by to get down to 1? So divide by 2. So you're going to divide everything by 2. This time it's nice because everything is just like a whole number, a regular number. It doesn't have that radical sign. So as long as it doesn't have that sign, you are good, and these are your answers. So it'd be 1. You're going to get 1 over 2 here and root 3 all over 2 here as well. Okay, so that's kind of a thinking question. You can see those come up in homework and whatnot. So just an idea of how to do that. Work for the lesson today. It's on page 2. Try to attempt all the questions. Those ones with stars get a little bit trickier. They might make more sense after tomorrow's lessons, but definitely give them an attempt, ask questions, and good luck.